Now let's go to determining the probabilities under the standard normal curve. So we know that a normal distribution is a standard normal distribution if the mean is equal to 0 and the standard deviation is 1. And if not, we can standardize a normal distribution by converting x scores into z scores. Alright? So also remember that the area, the entire area, the total area of the region under the normal curve is equal to 1. Meaning to say, the area of the shaded region in this normal curve that we have here, that is from the mean to the right, to the entire right of our curve, the shaded region is just equal to 0.5. Okay? Now, to compute for the probabilities under the standard normal curve, we have to make use of the z-table. So that contains the area under the one-tailed standard normal curve. So this table will be very essential for us to compute for the probabilities under the standard normal distribution. For offline learners, you may detach the page in your WLPs containing the z-table or this area under the one-tailed standard normal curve, because we will still use that in our next examples or next discussions. And for the online learners, please get hold of a copy of this z-table by browsing on the file named Areas under the One-Tailed Standard Normal Curve in the resources. Okay? Now, let's go back to our distribution here, or to our curve here. Alright? Now, let's try, let's have an example. So we have here, find the area under the standard normal curve when z is equal to 0.12. Okay, so we can find for the area using our z-table. So first, you need to identify your z-score, and that is 0.12. Okay, so using our table, 0.12 is 0.1 and 0.02, right? So let's highlight that. 0.1 and 0.02. So just locate the intersection of 0.1 and 0.02. We have 0.0478, and that intersection and that value already determines the area under the normal curve when z is equal to 0.12. Okay, so to illustrate, let's find first z is equal to 0.12. So where is z equals 0.12 in the curve? Of course, since it's positive, it's located to the right of our curve, so it's somewhere here. Let's estimate. It does not go beyond 1, so it's just about here. Alright, and shading that part, the entire region from 0 to z equals 0.12, that shaded region, it has an area of 0.0478, in which we determine this area with the use of our z-table. Okay? So that's how to illustrate areas under the standard normal curve. Now, let's have another example. Let's say here, find the area still under the standard normal curve when z is equal to negative 1.46. Negative 1.46 is a negative z-score. So locating negative 1.46 in our curve, it's somewhere here. Alright? And what we are trying to find out is the area from 0 to negative 1.46. So let's shade that region. Okay, so that entire shaded region. Okay, so to find the area of this shaded region, then we'll have to make use of the z-table. But we have to make clear that no area is negative. And since our curve is just symmetric about the mean, then looking for the area of a negative z-score is just equal to looking of the area of a positive z-score. Okay, so simple as that. Now let's find the area of our shaded region here. So our z-score is negative 1.46 and negative 1.46 okay, is just equal to negative 1.4 and 0.06. And since the area of a negative and positive z-scores are just equal, so let's find the intersection of 1.4 and 0.06. Okay, so that's 1.4 and 0.06, and the intersection is at 0.4279, and that is already the area of our shaded region. So from 0 to negative 1.46, the area is 0.4279. Alright, where did we get 0.4279? Okay, from the intersection of 1.4 and 0.06. That's 4279. So the area under, or the area of the shaded region, or the area from 0 to negative 1.46 under the standard normal curve is 0.4279. Now take note, class, that areas under the normal curves can also be used to determine probabilities under the standard normal curve. So in looking for the probabilities under the standard normal curve, all we need to do is to find the area. So same thing as what we did here. Okay, now let's have example. Let's have, okay, example A. Okay, find the corresponding probability of a z-score. It's the probability of z is equal to 1.51. So, as I said, probability is just equal to looking for the area at z equals 1.51 using our z-table. So, using our z-table, 1.51 is 1.5 and 0.01. So, 1.5 and 1.5 and 0.01, the intersection is here. So the area is 0.4345. Okay. And B, find the probability of z equals negative 1.51. And as what we have discussed earlier, the area under the normal curve of a negative z-score and positive z-scores are just equal because again they're just symmetric about the mean. So the probability of z equals negative 1.51 is still equal to the probability of z equals positive 1.51. So it's just 0.4345. Alright, now let's have our next example. Find the probability of z to be greater than 1.51. So we notice here that unlike our first two examples, which z is equal to negative 1.51 and z is equal to 1.51, in our example here we have an inequality symbol which is a greater than. Alright, so how to find the probability of z is greater than 1.51? So before we go use the z table, let's first illustrate the curve. So let's find 1.51 in the curve. It's positive, so it's somehow here. Alright, and since what we are looking for is greater than 1.51, so we need to shade the area to the right of 1.51 because these areas are because this area contains the values that are greater than 1.51. Okay, so this area shaded with pink is the area that we are looking for. Okay, this is the area that what we are looking for. So now, when we use the z table, what we are getting is the area from 0 to that corresponding z-score. Again, when we use the z-score at the z table, what we are getting is the area from 0 to that corresponding z-score. So when we use the z table and we locate for the area of area under the curve where z is equal to 1.51, then what we are looking for is the area from 0 to 1.51. And let's highlight that with yellow. Okay, so now using the z table, let's look for the area of the shaded region. Okay, so from 0 to positive 1.51, in our previous examples, we know that it is 0.4345. So that area shaded with yellow is 0.4345. Okay, now again, what we are looking for is the area of this pink region. So how do we do that? So let us remember that the total area under the curve is 1. Okay, if the entire area and if the entire region under the curve is shaded, then that area is equal to 1. So meaning to say, dear class, since 0 divides our curve into two equal parts because this determines the axis of symmetry, from 0 to the right is equal to 0.5, and from 0 to the left is also equal to 0.5. So how do we find the area of the pink region? Of course, we need to subtract. So to find the area of z to be greater than 1.51, we have 0.5 minus 0.4345. So using your calculators, it will give us 0.655. So the area of this shaded pink region is 0.0655. Okay? Now let's go to our next example. Let's have the probability of z to be greater than negative 1.51. So what we have here is still an inequality symbol. So first, let's illustrate our curve. So let's locate where is negative 1.51 is located. Negative 1.51 is somewhere here. Okay? Now, what we're looking for is the probability of z to be greater than negative 1.51. And since it's greater than, meaning to say we have to shade the part, we have to shade the entire right of negative 1.51. So shade the entire region to the right of 1.51, negative 1.51. Alright? Now, we already know that to get the area from 0 to negative 1.51, we need to use our z-table. Okay? And in our previous examples, we know that the area, okay, let's put a mark here. Okay, the area from 0 to negative 1.51 is 0.4345. Okay, right? Now, since what we are looking for is the entire right of negative 1.51, then we need to include also the entire region from 0 to the right. And we know that the other half of our curve is equal to 0.5. So to find the area of the entire shaded region, we need to add. So the probability of z to be greater than negative 1.51 is equal to 0.5 plus 0.4345. And that is 0.9345. So the entire area, which is shaded with yellow, is equal to 0.9345. Okay? Is 0.9345. So I hope it's already clear when to add and when to subtract 0.5 to our areas under the normal curve. Okay? Now let's have next example. Alright, now let's have here example E. Find the probability of z is less than 2.31. So we have here still less than symbol, so we need to illustrate first our curve. Let's locate where is 2.31 in our curve. So 2.31 is somewhere here. So since it's less than 2.31, that means we have to shade the entire region to the left of 2.31. So shading the entire region to the left of 2.31. Okay, we need to find the entire region of the area of the shaded region. Okay, now using the table, we can get the area of 0 going to 2.31. So from 0 to 2.31, let's use our z table here. 2.31 is equal to 2.3 and 0.01. So we have here 2.3 and 0.01. So the intersection is okay here. So that's 0.4896. Alright. So we know that the area from 0 to 2.31 is equal to 0.4896. And also, we know that the area from 0 to the entire left of the curve is equal to 0.5. So the entire region, the entire shaded region, is equal to the sum of 0.5 and 0.4896. So the probability of z to be less than 2.31 is equal to 0.5 plus 0.4896. That is 0.9896, meaning the area of the entire shaded region is 0.9896. Okay, now let's go to problem solving. So what we have here is a problem, and let's try to solve this one. The mean number of broadsheet copies sold at the stand is 32 with a standard deviation of 4.1. If the broadsheet copy sold over a month follows a normal distribution, determine the probabilities that for a randomly selected month, less than 31 copies are sold. So keywords here, we know that the broadsheet copy sold over a month follows a normal distribution. And since what we are given is mean and standard deviation that are not yet standardized, we need to convert 31 into its corresponding z-score so we can illustrate the given in this problem into the standard normal curve. Okay, so let's start first with the given. So your given is the mean, it's equal to 32, and standard deviation, which is equal to 4.1. And your x here is 31. So following the formula in standardizing a raw score, so you have z-score is equal to x minus the mean over the standard deviation. So that is 31 minus 32 over 4.1. That will give us negative 2.4. Negative 0.24. Alright? So now that we have already standardized our x value here, then we can now try illustrating our curve. Okay, so we have our curve here, and let's go back to what is asked in the problem. So if the broadsheet copies sold over a month follows a normal distribution, determine the probabilities that for a randomly selected month, less than 31 copies are sold. And since the corresponding z-score of 31 is negative 0.24, then what we are looking for is the probability of z to be less than negative 0.24. Alright? Now, alright, let's illustrate the curve. Okay, first we need to find or locate where is negative 0.24, so it's somewhere here. And since what we are looking for is a probability of z less than negative 0.24, so we need to shade the region to the entire left of 0.24. So shading the region of the entire left of 0.24, we have okay, so we need to find the area of that shaded region. So to find the area of the shaded region, all we need to do is to subtract the area of 0 going to negative 0.24 from 0.5. So that will be equal to 0.5 minus the area from 0 to negative 0.24, and we can find that from our z table or using our z table. So using our z table, the corresponding probability or area from 0 to negative 0.24 is equal to 0.0948, and subtracting 0.0948 from 0.5, we have 0.4052, and that is the area of our entire shaded region. So answering our problem here, we say that the probability for a randomly selected month to sell less than 31 copies of broadsheet is 0.452 or 40.52%. Okay? So that's all. I hope you learned something, and see you in our next video.